Yeah, you know what it is. SOHCAHTOA, 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 SOHCAHTOA. Yeah, you know what it is. SOHCAHTOA, 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 SOHCAHTOA. Yeah, you know what it is. When I'm doing math, I do it big. Yeah,
Okay, let's get started on some trigonometry. Unit 8, Video 3. Grab those vocab books. Okay, so we're starting off trigonometry. Trigonometry is a branch of mathematics that studies the relationships involving the lengths and the angles of triangles. So it's the study of triangle measures. All right, so take a look at this right triangle that we have here. Okay, see we have this angle here. We call it angle X. It could be called angle A. It could be called angle theta, which is a Greek letter. Okay, we'll talk more about that later. But if we go off of this angle right here, what side is opposite of this angle? Is this side opposite, this side, or this side? Well, opposite will be across from it. So this side is opposite of this angle. Now, what side is adjacent? That means next to. Well, that would have to be this one. It's next to the angle. And then, of course, we all know the hypotenuse. That's the one that's across from the 90-degree angle. So it's important that we know what is opposite, what is adjacent, and what is hypotenuse according to this angle right here. If I were working with this angle, then the opposite side would be over here, and the adjacent would be here. And of course, our hypotenuse doesn't change. It's always across from the 90. So we're going to be practicing that today. Let's go on to our next word. Okay, next thing we need to talk about are trig ratios. So trig is just short for trigonometry. And ratios, we've been working with those. Those are just the fractions that compare two numbers. So when we talk about trig ratios, we use the word sine, cosine, and tangent. Okay, sine we abbreviate with SIN. Cosine we use COS. And tangent TAN. Okay, well, trig ratios allow us to find missing lengths and angles of right triangles. So if you look over here, you might have heard of this before. SOHCAHTOA. SOHCAHTOA. SOHCAHTOA is a way for us to remember our trig ratios. So here's sine. This little symbol right here is the Greek letter theta. You might have seen that before. So this is sine of theta equals, what do you think the O stands for? And the H? Well, the O stands for opposite, and the H stands for hypotenuse. Okay, so we will use SOHCAHTOA to help us remember that sine is opposite over hypotenuse. And the ka part is cosine. The C stands for cosine, and that's adjacent over hypotenuse. Adjacent over hypotenuse. And then we have T, that's for tangent. So tangent of theta is equal to opposite over adjacent. So we use SOHCAHTOA to help us remember how to write our trig ratios. So if we're asked to find sine of theta, we'll just find the opposite side and put it over the hypotenuse. Opposite over hypotenuse. If you're asked to find tangent of theta, you find the opposite side and put it over the adjacent side. We definitely need to practice this, and we're going to get a lot of practice throughout the next few days and weeks, actually. So you'll become an expert with trig ratios in no time. Okay, so make sure you put your title, Intro to Trig, and we're asked to write 3 trig ratios for angle X. So here's angle X. I'm going to go ahead and Mark that. Here's angle X. We're going to be working with that. So we have to come up with sine of X, cosine of X, and tangent of X. Okay, because we know the angle name is X, we're not going to use theta, we're going to use X instead. So before you start writing your fractions, we need to label the opposite, adjacent, and hypotenuse. So the hypotenuse is easy to find, right? It's across from the 90-degree angle. So this is going to be our hypotenuse. Okay. Opposite will be across from our angle. So this is going to be our opposite side. And then adjacent is right next to our angle. So this is going to be adjacent. I'll use ADJ for adjacent. So we need to write, I'm not going to put a little answer box because I need some room to write three different fractions. So we need to first find sine of X. Well, sine of X, if you look over here, sine is opposite side over hypotenuse. So it's opposite over hypotenuse. So the opposite side we have labeled as 5. And the hypotenuse is 6. There's one answer. The next one we have to find is cosine of X. Cosine is A stands for adjacent over hypotenuse. So adjacent over hypotenuse. So adjacent over hypotenuse. Well, we labeled the adjacent side here, so this is 3, and the hypotenuse is 6. So adjacent is 3, and hypotenuse is 6. Okay, I'm not going to worry about reducing that right now. Okay, next thing is tangent of X. Well, tangent is opposite over adjacent. Opposite over adjacent. So, opposite over adjacent. The opposite side is 5, and the adjacent side is 3. So those are all three of our trig ratios. Now, I understand this doesn't make any sense as far as helping us find a missing side because we already have all the sides. Okay, today we're just practicing setting our trig ratios up because soon we won't have all these sides. We'll have an angle and only one side, and we have to use trig to find our missing sides. Okay, so we're not going to be able to use Pythagorean theorem or our special right triangles because they won't be 30, 60, 90. Say this were 37 degrees and we only had one side. What are we going to do? We can't use Pythagorean theorem. So that's when trig comes into play. So knowing how to set up your trig ratios will help you find missing sides of any right triangle when you only have an angle and a side. That'll make more sense later when we get more practice. Right now, we just need to learn how to set everything up. Let's try another one. Okay, number 2 looks pretty similar to the last problem. Now we're working with angle Y. So, angle Y, we're working with this one. Okay. We have to write all three trig ratios, so we need to find sine of Y, cosine of Y, and tangent of Y. Okay, and they're going to be fractions because we're writing trig ratios. So we need to figure out what is opposite, hypotenuse, adjacent. So we need to go ahead and label those. So the hypotenuse, that's kind of easy. That's right here. Hypotenuse. Now, opposite would be across from the y, the angle y. So this would have to be our opposite side. And then adjacent would be next to it. So this is going to be adjacent. Okay, now that we have everything labeled, we just need to write it as a fraction. So sine is opposite over hypotenuse. So our opposite is 4 and our hypotenuse is 5. Okay, for cosine, it's adjacent over hypotenuse. Adjacent is 3 and hypotenuse is 5. Tangent is opposite, which is 4, over adjacent, which is 3. Those are our trig ratios. And we'll actually be able to apply them and find missing sides and all that later. Okay, last problem. Now we have to find the 3 trig ratios for this triangle, working with angle theta. So here's angle theta. Don't let that confuse you. I could have easily just put an X right there, but you are going to see that Greek letter sometimes, so let's get it in your notes. So we're going to need to find sine of theta, cosine of theta, and tangent of theta. And they're going to be fractions. So we need to label our sides. Here's our right angle. So 17 would be our hypotenuse. Okay, we have to go from our angle we're working with, go to the opposite side, and 8 would be our opposite. And then 15 would have to be our adjacent. That means next to. Our adjacent side. So, sine is opposite over hypotenuse. So opposite is 8 and hypotenuse is 17. For cosine, it's adjacent, which is 15, over hypotenuse, 17. And tangent is opposite over adjacent. Those are our trig ratios. Take a look at some of the careers that use trigonometry. Okay, for our purposes right now, we can measure, say, the flagpole. If we wanted to know how tall the flagpole was, but we really don't have a measuring device to measure it, we can use trig to figure it out without actually going all the way up to the flagpole. Or maybe there's a big building and you want to know how tall it is. You can use trig to figure it out. And we're actually going to be doing that. So, something to look forward to. Take a look though. Look at all these jobs that use trigonometry.
On your mark, ready, set, let's go. Trigonometry, bro, I know you know. I go psycho when I see a triangle. You just can't sit. You gotta get tricky with it. Oh, that's it. 3 angles, 3 sides. T-R-I-G, all up in my eye. Soka, Toa, will tell you where to go. You just gotta know about H and O. Everybody looking at a glance at the box. The HYP is sitting across. Theta, theta, is after eta, eta. So on it, for the look, I don't mark it.
Have a great day.